Welcome DEKWP, 小工 Abor. Your learning journey starts now. Ever felt like dynamic programming is a secret code? You see all these fancy terms, state, decision, transition, and your brain just throws up its hands. Why is this optimal substructure thing so tricky? How do we even know if our little step-by-step choices actually lead to the grand prize? It's like trying to assemble IKEA furniture in the dark. That's where the real fun begins. So, how do we fight this fog? Enter our superhero, the DIKWP model. Think of it as a five-layered brain squad. First, you've got data, the raw ingredients, like numbers or facts. Then, information, giving those data points context, like saying this temperature reading was at 3 p.m. Next, knowledge, the rules, the patterns, the how-to. Then comes wisdom, using that knowledge to make smart choices, like picking the best path. And finally, purpose, the ultimate goal, the why we're doing all this. Now, here's the cute part. Unlike old pyramids, DIKWP is a web. Layers talk to each other, feedback loops everywhere. It's like a team chat, not a rigid hierarchy. This interconnectedness is key. Okay, let's put DP and DIKWP together like peanut butter and jelly. When you define a state in DP, think data plus information. What specific details are needed to describe this tiny problem? Stage? That's mostly information, telling us where we are in the process. Making a decision? That's pure wisdom, choosing the best option based on our goal. The transition equation? That's knowledge, the rule book for moving from one state to another. And the big boss, the optimal principle. That's purpose plus wisdom working together, ensuring every single choice aligns with the final goal. Take the classic 0 minus 1 knapsack. F of I, W equals max of F of I minus 1, W, V. I plus F of I minus 1, W minus WI. See? The max function isn't just math. It's wisdom evaluating options based on the purpose of maximizing value. Suddenly, those abstract steps have a clear meaning. So, how do we teach this magic trick? Forget starting with formulas. Start with a purpose. What exactly are we trying to achieve? Then, figure out the wisdom. What smart choices need to be made along the way? Next, dig into the knowledge. What are the underlying rules or patterns? Define the information needed for the state. What variables capture the essence? Finally, ground it in the data, the raw input. Think of DIKWP as a checklist. Is my state definition complete enough? Am I making decisions that truly serve the overall goal? This flips the script. Instead of memorizing steps, students build a logical flow from the big picture down to the nitty-gritty details. No more black boxes, just transparent reasoning. And that's the game changer. DIKWP doesn't just explain DP, it demystifies it. It connects the dots between abstract concepts and concrete actions. You start seeing the why behind the what. Looking ahead, this kind of semantic thinking could be huge for AI, making algorithms more understandable. Plus, this framework isn't just for DP, it's a powerful lens for many other complex problems. So, next time you face a tough algorithm, ask yourself, what's the data? What's the information? What's the knowledge? What's the wisdom? And what's the purpose? That's your DIKWP roadmap to clarity.